my drink needs a little ice.
Do you ever wonder why ice floats instead of sinks?
Yeah, why does it float in the first place?
Maybe because of density.
Well, what is density and why does it matter?
Let's find out on today's Sunday Science!
What is mass? Well, to start off, mass is not weight. Mass is the amount of matter that is present in an object, while weight is a totally different thing. Say, for example, I take this water bottle, okay, and I take it to the moon. On Earth, it has 16 ounces of water, and the amount of water isn't going to change depending on where in the universe this water bottle is. It will always have 16 ounces of water. Moving on. The greater mass an object has, the greater its inertia. What is inertia? Well, inertia is the tendency an object has to change its state of motion. An example of this would be, I am pushing a bike, and Sanika is pushing a car. It is way easier for me to push and stop the bike because it has a lesser mass, therefore a lesser inertia. And it is much harder for Sanika to push and stop a car because it has a greater mass and a greater inertia. This is mass, and next up is what is weight.
What is weight? Weight is the measure of a gravitational pull on an object. The stronger the gravity, the stronger the weight. Let's understand by taking an example of planet A and planet B. Let's take an object with the mass of m and put that object on both planet A and planet B. The pull of gravity on planet A is x units, and the pull of gravity on planet B is 2x units. Clearly, the pull of gravity is greater on planet B than it is on planet A. So the weight of the object on planet B will be 2 times greater on planet A, even if it has the same mass, or m. Weight is the measure of gravitational force acting on an object.
How can we understand weight? By using a formula. We can find out by using Newton's second law of motion, which is that force acting on an object is a product of its mass and acceleration. The force due to gravity is nothing but the weight of the object. Therefore, weight equals mass times acceleration due to gravity. We know the unit of force is newtons, so we also know that the unit of weight is also newtons. As the value of gravity is constant, we also know that the weight of an object is directly proportional to its mass.
While most people think that mass and weight are interchangeable, they are in fact two separate things. Think of it as mass deals primarily with the matter present in an object, while weight is a force. On Earth, weight is the gravitational force exerted by the Earth on the object. More importantly, the weight has a direction associated with it, and on Earth, that direction is towards the center of the Earth. For this reason, weight is called a vector. On the other hand, mass does not need a direction to define it, so it's called a scalar. With mass, an object could be placed anywhere, whether that be Earth or an entirely different planet, and the mass would remain the same. Whereas with weight, after considering gravitational pull, the value of weight may change. Weight and mass are so interchangeably used in today's current day and age that if someone asks you your weight, and if you answer in pounds, you're actually telling them your mass, not your true weight. Then again, maybe telling someone your mass is better, since if you tried to tell them your true weight, you would have to convert your mass to newtons, and then phrase it something like 445 newtons towards the center of the Earth, which is highly inconvenient.
What is density? Well, density is a substance's mass per unit of volume. In order to calculate density, you must use a specific formula. The formula is as follows. Mass divided by volume equals density. But to fully understand density, you have to know that whenever there is more stuff in a certain space, there is more density. So the more mass of something you have, the denser it'll be. Let me show you some examples of density in the real world. Say you've decided to ride a hot air balloon. You might already know that the hot air is what keeps the balloon up. But how? Well, inside the balloon, the air is heated up by a small fire. The hot air molecules rise up, thus letting the balloon float. This happens because the hot air is way less dense than the surrounding cooler air. Another example where we can apply this concept is in a two-story home, like the one you may live in. When you turn on the heating, you may notice that the second level is always warmer than the first. This is due to the same reason in the hot air balloon example. Warm air is always less dense than cold air, which is why it moves to the top.
Today we'll be doing an experiment to explain the concept of density. For this experiment, you'll need 2 cups, salt water, regular water, and 2 eggs. To start, put the salt water in 1 cup and the water in another. Make sure that you add a lot of salt when preparing the salt water. Okay, first you're going to add the egg in the regular water. As you can see, the egg is sinking. This is because it is more dense than the surrounding regular water. Now we're going to add the other egg into salt water. Make sure you add the eggs very gently. Well, you can see that the egg is floating now. This is because the salt, when it dissolves in fresh water, the density of that water increases. The mass amount of stuff the water contains increases, and the volume stays nearly the same. The more salt that is added to water, the denser it becomes, which is why this egg is floating in salt water. And the same effect also happens in the Dead Sea, where the salt content is 10 times saltier than most oceans.
Before, we will also be doing an experiment to exhibit density. Here, in this test tube, we have 3 different liquids with 3 different densities.
Those liquids are milk, dish soap, and oil.
Out of the 3 liquids, you can see that milk is the densest because it's at the bottom, followed by the dish soap because it's in the middle, meaning that it is less dense than milk but denser than the oil. Out of the 3 liquids, oil is the least dense because it's at the top.
Like liquids, solids also have density.
The solids we are using today are tortilla chips and uncooked pasta.
Let's start off by putting our pasta into our test tube. It's floating to the bottom towards the milk, meaning it should have the same density as the milk. The tortilla chip stays at the top, meaning it has the same density as the oil.
Thank you for watching,
And see you next time
On Sunday Science!